Hi everyone, welcome. Thanks for being here. It's great to be back at another .NET Conf. I'm Daniel Roth, Principal Product Manager for ASP.NET Core and Blazor. And in this session, we're going to learn all about the new features and improvements in ASP.NET Core and Blazor for .NET 9, which just released today. ASP.NET Core is a full-stack web framework that provides everything you need to build modern web apps. Whether you're trying to build beautiful Blazor web UIs or scalable back-end services, ASP.NET Core provides everything you need end-to-end in a complete solution, including high-performance servers, built-in security features, and excellent tooling. So, what's new in ASP.NET Core for .NET 9? Well, ASP.NET Core in this release is loaded with new features and improvements. First and foremost, the team has been focused on quality and fundamentals. This includes extensive work on performance, accessibility, and security. Your ASP.NET Core apps are built to help ensure that your apps are secure by default and ready to handle even the most extreme workloads. We've also made a bunch of improvements to the web development experience. We now have built-in support for open APIs, lots of Blazor enhancements, and lots of improvements to tooling and debugging. And then when you're ready to publish your ASP.NET Core app to the cloud, it's ready to go, thanks to expanded support for ahead-of-time compilation, as well as improved monitoring and tracing. Now, .NET 9 is the fastest release of ASP.NET Core yet. You get industry-leading performance. You get higher throughput with lower memory usage, thanks to the new adaptive garbage collection. On the TechEmpower JSON benchmark, we're seeing 15% higher throughput with 93% less memory usage on a high core count machine. Your Blazor WebAssembly apps start up faster. We're seeing them start up 25% faster on the Google Lighthouse scores. And your Blazor server apps are more responsive thanks to WebSocket message compression. Your static web assets, like the static files in your app, are automatically optimized with pre-compression and fingerprinting so that they can be efficiently downloaded and cached. Now, the ASP.NET Core team has also been heavily involved with .NET Aspire. .NET Aspire is a powerful set of tools, templates, and packages for building observable, production-ready apps. And it has something to offer to every ASP.NET Core developer. It includes a streamlined development experience for modeling and running your entire app. It includes a built-in developer dashboard so you can monitor and trace your entire application. It includes integrations for popular services and systems like Redis, PostgreSQL, Azure services, and so on. And it also integrates with other developer ecosystems too, like JavaScript and Python. It has a comprehensive and flexible deployment model so you can publish your entire app to whatever cloud you'd like. And your .NET Aspire apps are production ready thanks to smart defaults for OpenTelemetry, health checks, and resilient retry logic. If you haven't tried out .NET Aspire yet, you should, and you can do so by going to .net/Aspire. It's actually really easy to add .NET Aspire and all its great features to an existing ASP.NET Core app. Let me show you how. All right, so I'm going to pop over here to Visual Studio, and I have a simple Blazor web application that I'll just go ahead and get running so you can see what it does. This Blazor web app it's just the default Blazor web app, but it's set up so that the weather page calls a backend API that's in a separate process in order to get the weather data. So we can see the home page, the counter, and if I browse to the weather page, well, currently it doesn't show anything, and that's because I didn't start the API project yet. So let's go ahead and start that. Let me go back to Visual Studio, select the API project as the startup project, get that running. And then once I have both processes running, I should be able to go back to the browser, refresh the page, and yeah, there we go. Now we can see our weather data. Okay, so how can .NET Aspire help with an app like this? Well, .NET Aspire really elevates the development experience when working with a distributed app, an app that has lots of different processes that need to be coordinated. It's really easy to add .NET Aspire to my application. I can just right-click on the Blazor app, and I'm going to select Add .NET Aspire Orchestrator Support is the option I'm picking here. Now that might sound a little scary at first. Orchestrator, what is that going to do? Is that going to set up some sort of Kubernetes cluster, or am I going to have to mess around with containers? No, it's actually going to do something very simple. It's just going to add these two projects. It's going to add an app host project, which will let me model and run my entire app. And then it will also set up this service defaults project, which includes some convenience code for setting up production-ready defaults for my application. And then up above, we just pick the project prefix name that we want to use, and we can go ahead and click OK, and that will add those two projects to my solution. Now let's take a look and see what those projects actually contain. Let's go into look in the service defaults project first. So I'm just going to open up the extensions.cs file. This is just a C# class library with some helper methods. So here first we have the add service defaults method. What does this do? Well, it's going to set up open telemetry. It's going to add health checks. It's going to set up service discovery. Service discovery is a .NET Aspire feature that makes it really easy for services to call each other. And then it will also set up a resilient retry logic so that when we make those API calls, if anything goes wrong, they can just retry them. Down at the bottom, if we just look down here at this other method, there's this map default endpoints method that will just set up two endpoints for health checks, the /health and /alive endpoints. Okay, so now if we look in our Blazor project, the only change that was really made to our Blazor project was it added a reference to that service defaults project, and then you can see that it's calling those two helper methods, the add service defaults and the map default endpoint, so that it's set up and ready to go. There's no magic happening here. It's just some helper code that makes our app more production ready. All right, let's now look at the app host project. If we look in program CS for the app host project, it's pretty simple. This is where I can model my entire application. And you can see right now that the app host project really only knows about the Blazor app as part of its distributed app model. Doesn't know yet about the API project. We should add that, so let's add it. I'm going to right-click on the Weather API project and do exactly the same gesture. Select Add .NET Aspire Orchestrator Support. Now here Visual Studio is detecting that I already have an app host project, and it's saying it's just going to reuse it. And that's great. That's exactly what I want. Go ahead and click OK, and then that should add the API project to my app host, and there it did. Now I do want to do one more thing. I want to model the fact that my Blazor app depends on that API, like it makes calls to it. And we can model that just using normal C# code. So I'm going to move the API up here to the top, and then I'm just going to capture that as a C# variable. There's my API. And then for my Blazor project, I'm going to say that this has a reference with reference to that API. Okay? And now I'll do one more thing. I'm also going to say that this has external HB endpoints. That's just letting Aspire know that the Blazor app is a thing that should be exposed to my end users. And that's it. Now I've modeled my entire application. Pretty simple. So now, because our app is modeled, we can start using cool Aspire features. Like, for example, we can use service discovery. I'm going to copy the name of the API project that we've set up here in the app host. And let's go over to my Blazor app. And here in Program CS, you can see this is where we're configuring the Weather API client. And you can see that it's currently just using a hard-coded address. And I could use config to set up a different address for local development and production development and do that for all my APIs. Or I could use Aspire and just use this convention where I specify the name of the API project that I've modeled, and now Aspire will take care of resolving that address to the actual address at runtime. I don't have to go messing around with config files. So that's service discovery. All right, now let's run the app. Now to run this app, because I'm using Aspire, I can just select the app host project as my startup project, and it knows about all the pieces of my app. It knows about the, I think I have the app currently running. Let me shut it down. There it goes. OK. So it knows about all the pieces of my app. So it can get each of the pieces running. It can start the Blazor app. It can start the backend API project. And what's really great is it also gives me this awesome developer dashboard where I can see all the pieces of my app. I can see the Blazor app. I can see the API. I can click on them and get some more details about those projects. I can select the actual endpoints for those processes and browse to the Blazor app. Let's see if the weather page is actually working. It is. So service discovery is doing its thing. That's awesome. We can also see in the dashboard all of the console output for the Blazor app and for the API project right here. We can see all of the logs in a structured form on the structured logs tab. We can filter and select different log levels. We can see all the distributed traces for our application to trace all the activities as they flow through the app. Like down here at the bottom, you can see that this is where we browse to the weather page, and then that triggered an API call to our weather API, and we can see all those activities in the entire flow. Super cool. And then in the metrics tab, we can see the various metrics for our app. Like here's information on how many active requests we have and their request duration with lovely charts and graphs. So a super useful tool when you're doing development to help you see what's going on in your distributed app and to troubleshoot and diagnose problems. Now, when we're done developing and we're ready to publish this app to the cloud, that's really easy. We can actually just right-click on the app host project, say publish, and say, you know what, I just want to publish this to the cloud in one shot. And we have the option of just, because the app host knows about the entire model of the application, just saying, let's just publish everything to Azure Container Apps and get it running. It's really, really convenient. Any containers that I'm using in the app can also be hosted there as well. But you don't have to do that. If you have a publishing flow that's already working for you, you can continue publishing the pieces of your .NET Aspire app wherever it makes sense for you. Purely optional, but super convenient when you're just trying to get up and running. So that's .NET Aspire. It really elevates the development experience. It makes it easy to deploy your app to the cloud. And I think it just adds a whole bunch of features and value to every ASP.NET Core developer and to existing ASP.NET Core projects. Really easy to add. Now, I love the dashboard. The dashboard is super useful, great way to monitor and inspect your app. But what I love even more about it is that it's built using .NET and Blazor, using .NET technologies. The Aspire team used the Microsoft Fluent UI Blazor components to build this dashboard, and that really enabled them to innovate and iterate fast. If you're not familiar with these components, the Fluent UI Blazor components are a set of free, open source, 60 or more components that follow the Microsoft Fluent UI design pattern. If you're interested in using them for your next Blazor project, you can find them at aka.ms/blazor/fluentui. Okay, well, speaking of Blazor, what's new in Blazor for .NET 9? Well, Blazor is our full-stack web UI framework that ships as part of ASP.NET Core, and it lets you render your web UI however you'd like. You can do it fully server-side rendered, all the way down to fully client-side rendered, like you would with a single-page app. And in .NET 9, there's lots of new Blazor features and improvements. We've added a new API so you can detect the current render mode for your components at runtime and then adjust how those components are rendering accordingly. We've made some improvements to the reconnection logic in Blazor when using interactive server rendering. Interactive server rendering is when you're rendering the components from the server and handling all the UI interactions over a connection with the browser, like a WebSocket connection. If that connection gets lost, Blazor will automatically try to reconnect, and we've made some improvements to that experience in .NET 9. We've also made it simpler for you to set up static server-side rendering in a Blazor app that was otherwise set up to be globally interactive. Like maybe you have a Blazor app that's configured to run fully on WebAssembly, but then you realize you have one part that you really want to render using static server-side rendering. That's now much easier to do in .NET 9. We've simplified the serialization of Blazor authentication state, so it's easier to flow the authentication state from the server to client, and we give you built-in components and classes for doing that. Blazor components now support constructor injection, so you can inject services into your components. And we have a new Blazor hybrid plus web project template that makes it really easy to set up a Blazor app that targets not only the web, but also native mobile and desktop clients. Let me show you some of these new Blazor features. Let's go back to our Blazor web app, and let's look first at the counter component. So here's the counter component. It lives in the client project, and it's using the interactive auto render mode. What is that? Well, interactive auto means that this component will automatically choose which render mode to use at runtime based on whether or not the .NET WebAssembly runtime has already been made available. If the .NET WebAssembly runtime was already downloaded and cached, then this component will use it. It will run on WebAssembly. If it hasn't been, then the component will use interactive server rendering, run from the server, while it downloads the .NET WebAssembly runtime in the background. Now in .NET 9, we can actually see all of that happening using a new API that we've added that allows you to detect the render mode for the current component. So I'm going to add another heading here, and I'm just going to display the current render mode for this component using the new renderer info API. And I'm just going to display the name of the render mode so we can see what it is. And then down below, we have this button, right? And the button has an on-click handler. And that on-click handler will fire when the component is interactive, like if you're clicking on the button. If the component was rendered statically, though, like when you're pre-rendering it, then that on-click handler doesn't really do anything. And there might be a little delay between when it gets pre-rendered and when it's actually set up for interactivity. So maybe we want to do something about that in our rendering logic. So I'm going to add an if check here and say, you know what, if the renderer info tells me that this component is interactive, running on WebAssembly or running over the WebSocket connection with the server, then we can go ahead and render the button. That should work fine. But if it's not, then maybe we do something else. Like in this case, let's just render a static placeholder that says, 1 moment, please, while we get things, interactive. Okay? So we should now be able to just, let's hot reload that into our running application and go back to the web app. Let's browse to the counter page. And yeah, okay, cool. So we can see now that the render mode is currently WebAssembly. It's running on WebAssembly and it's interactive. I can click on the button and the count goes up. But if I refresh the page, watch carefully. You see briefly it says that it's static and then it shifts over. Let me see if I can freeze it for you. Refresh and there, okay. So right now it's saying that the render mode is currently static. Why is it static? Well, that's because initially we pre-rendered the component from the server. The component, the browser sends a request, goes to the server. We rendered the counter component just to plain HTML into the response so that the browser gets pixels on the screen as fast as possible. And it's not interactive yet because we haven't started the WebAssembly runtime, so we see our placeholder text. But if we let it continue to render, the WebAssembly runtime boots up and now it is fully interactive and we see our counter button. Okay, so that's how you can adjust how your components are rendering based on the currently active render mode. Now, we didn't see the whole full interactive auto thing happening. We didn't see this actually use interactive server rendering. In this case, the .NET WebAssembly runtime was already cached. If we want to see that, we can just go in and clear the site data so that the WebAssembly runtime is no longer cached. And if we refresh the page, we'll see there. It briefly was static, and then it shifted over to server, interactive server rendering. So now it's handling interactivity over the WebSocket connection. Cool. OK, so that's the new renderer info API. Next, I want to show you the improvements to the reconnection experience when you're using interactive server rendering. Now, with Blazor, interactive server rendering works over that connection, that WebSocket connection. And if the connection gets lost for whatever reason, like a network blip or whatever, we have a default user experience in Blazor that will let the user know, hey, hold on, the app can't currently connect, please wait. And honestly, in prior .NET releases, that default user experience wasn't great. It was sort of a white overlay over the entire app. It was a bit clunky, a bit jarring for the end user. And when the app actually successfully reconnected, if something happened to the server state, let's say the server rebooted, it went down and came back up, and so any in-memory state was lost in addition to the connection, then the app wouldn't be able to connect. It might be able to make a network connection, but it couldn't connect back to the server state. And then the app would just be like, hey, user, I'm sorry, I can't connect to back what you were doing. Please refresh the browser if you want to keep going. You had to manually refresh the browser. So in .NET 9, we wanted to improve that a bit. So we make some improvements to the reconnection experience. So let me snap this side by side with the Aspire dashboard. And what I'm going to do is I'm going to use the Aspire dashboard to shut down the Blazor app. That should kill the connection, and we'll also lose any of the server state. Okay, and so here's the new reconnection UI that we provide by default. A little cleaner, a little more friendly. You can, of course, customize this however you'd like and make it look however you'd like, but at least the default experience is a little less jarring. And then if I restart the application, once the app comes back up, Blazor should be able to reconnect. There it goes. It already did it. It's really quick. Blazor's able to reconnect, and it detects that the server state's gone. You can see that that's true. Our counter is no longer what it was. It's back to 0. But at least it automatically refreshed the browser and got things working again for the user. If you want to persist that server state, you can still do that yourself in your app logic. Save it someplace and then reload it again when the user reconnects. But at least the reconnection experience now is much smoother and more friendly for your end users. Okay, so that's the improved reconnection experience. Last Blazor feature I wanted to show you is the new Blazor Hybrid Plus Web Template. So for that, let's switch to a different project. I'm going to go into Visual Studio and do File, New Project, and let's bring up the Blazor Hybrid templates. There they are. Okay, so here is the new one. We now have a .NET MAUI, Blazor Hybrid, and Web project template. Blazor Hybrid is a way to run Blazor components in a native client app, natively on the device, and then render them to an embedded web view control, okay? And now you can create both a Blazor Hybrid app using .NET MAUI, as well as a Blazor web app, so simultaneously, let's go ahead and save that, simultaneously target web and also mobile and desktop, and web. So this project template will now set all of that up for me. So if we look at what this has got in the Solution Explorer, let's collapse these down a little bit. So here we have the .NET MAUI project. That's our Blazor hybrid app. That's what's going to target, Mac, Windows, iOS, and Android as like native clients. Then we also have a web project. That's just a standard Blazor web app. And then we have this shared project, which has all of our Blazor code. All of our Blazor components live in here. So we got our counter component, the home component, the weather component, and so forth. Okay. So let's see if this works. I think I'm going to try and let's run the web app first. And let's go ahead and run that. Do we have anything else running? Let's make sure. Yeah, nothing else running currently. Get that building. So that should run our Blazor components in the browser. Okay, there it goes. Take it a second. There we go. All right, yeah. Took a little minute. My laptop's being a little slow. All right, so we've got our Blazor web app. Whoa, Blazor web app. Whoa, what just happened? I don't know what just happened. Let's try it again. Okay, so it says it's running. Let's get it. Do I just need to browse to it? Let me just browse it up again. I think I did something weird with Edge really quick. There we go. Okay, so there's our Blazor web app running in the browser. And then let's now get this running as a native client. So I'm going to switch over now to the MAUI project. And let's run this as a Windows desktop app. So these are the same components. So they're all from that shared class library. Before we were running them in the browser, and now we're going to run them in a native Windows desktop client that's built with, it's .NET MAUI, but it's under the hood. It's using WinUI 3, and it's using WebView 2 for the WebView control. So give that a second. So we got web working. Let's get the Windows desktop up and running. Let that build. There we go. OK, cool. Working. So now we have a Windows desktop client using those components. And then we can also choose that we'd like to run on a mobile device. Like I want to target Android, we can run it on mobile. Now my laptop's a little slow. So instead of trying to do the full deployment, which can take like a minute or so, I've just got the app previously deployed to the Android emulator. And there is the same app now also running on a mobile device. So we've got web, we've got desktop, and we've got mobile, all with one set of Blazor components. Now you could do this with .NET 8, but you had to manually set it all up, like create all the projects and piece them all together. In .NET 9, you've got an existing template that you can use to target all of these platforms in a really convenient way. Cool. So that's the new Blazor Hybrid plus web template and all the other Blazor improvements. Now this technique of using Blazor to target web, mobile, and desktop is what Aspen Publishing used to build their new Leaf audiobook learning app. Leaf is a learning app for law students that gives them access to Aspen's extensive library of legal learning materials. They used Azure AI's speech synthesis to generate smooth and natural-sounding narration so that their students get a dynamic learning experience while they're on the go. And by using .NET as a common platform, Aspen was able to onboard new developers onto the Leaf project really easily and get them productive fast. So a great way to leverage .NET to really amplify your innovation. All right, what's next? Let's take a look at optimized static web assets in .NET 9. So pretty much every web app has static files, static web assets as part of the application. And typically those files are known as part of the build, at build time. So in .NET 9, ASP.NET Core will now collect all the information about your static web assets and then use that information to optimize them as when you then go to publish your application. The optimizations that it will perform, it will do pre-compression at publish time, where it pre-compresses all your uncompressed static assets, not just your Blazor ones, but like your CSS files, your JavaScript files, so that they're as small as possible. They will fingerprint your static assets, so they have unique names based off of their content using a content-based hash. And that enables ASP.NET Core to then aggressively cache those files without having to worry about stale versions of the files being served. All the static web assets are also now surfaced as endpoints using endpoint routing, which means that static web assets now works with all the endpoint-aware features in ASP.NET Core, like authorization, for example. You can add authorization policies to your static files. Let me show you what this looks like. Let me close down all the Maui stuff. I'm gonna switch back to my other Blazor web app. Okay, make sure I don't have anything else running. Let me close down that. Great. Now let's look in the Blazor Web Apps program CS file. And down here, we can see that this Blazor app is not using the existing static file middleware for handling static files, which is still there, you can still use it, but it's instead using the new Map Static Assets API. Map Static Assets will take all your static web assets and surface them as proper endpoints using endpoint routing. And it does that using metadata that gets collected during the build. And then when you go to publish your app, all those files get automatically optimized. They get pre-compressed and fingerprinted. Now to use those optimized files, we also have some APIs that you can use in your app. Let's go in here and look at the app.razor file for our Blazor app. And here you can see that we're using this new assets API to map the path to the static asset to the optimized version, like the fingerprinted version and the pre-compressed one. There's also a new import map component that we've added in .NET 9. This will create a JavaScript import map that will enable you to automatically use the optimized JavaScript files when you're importing any JavaScript modules. If you're using MVC or Razor pages, like you're in a CS/HTML file, all of the tag helpers will automatically use the optimized static web assets as well. And we also have a new tag helper for generating an import map in CS/HTML. Okay, now to see all these optimizations in action, we really need to publish the app. So I'm going to right-click and publish this app. I can just publish it locally to the file system for demonstration purposes. I did that previously just to save on a little time. And I'm just going to go ahead and run the published version of that Blazor app. Okay, let's browse to that and see what we get. Okay, so now let me bring up the browser DevTools. And let's go to the Network tab. And then I'm going to just right-click and empty the cache for the browser and hard refresh so we can see what this app looks like on the initial load. Okay, a couple things I want to call out here. Look, first, let's notice that all the files now have fingerprinted file names. They've got these content-based hashes in their file names so that they are unique based off their content. We can also see that like this bootstrap file, this guy right here, notice that its download size is only 23 kilobytes. Now, if we hop back out and hover to see what the real size of that file is, the real size of that file is like 233 kilobytes, much larger. So we were able, this is because of pre-compression. During the publish step, we were able to compress that file as hard as possible using Brotli compression to make it really, really small. So you get a much better compression ratio than you would if you're using runtime compression. And it also unburdens your server from having to do any of that compression work. If we click on the file, let's see some more additional details about how it was served from the server. We can see that the cache control header that was sent says that this file is immutable. That's basically ASP.NET Core telling the browser, hey, this file is never going to change. Feel free to cache it as long as you want. If it ever changes, I'm going to use a different file name, so don't worry about it. So aggressively caching it there. You can see there's also the content encoding for Brotli. So we're using the pre-compressed Brotli file. Also, the E tags are now content-based instead of last modified-based. That's nice if like any of these files are like being produced as part of your build, and they didn't really change, but the timestamp changed. So now you'll still get cache versions even in those types of situations. But long story short, if we pop back out to the network tab and then refresh the page, look at all those zeros. So pretty much everything in this app is now being served from the cache without even having to send a request to the server. And even in the case where we do send a request to the server, like for the Blazor WebJS file, you can see it's still, the ETag logic is kicking in and saying, hey, this file wasn't modified. Feel free to use the cache version. So you get much more optimized distribution of your static web assets in .NET 9. Let's hop back here. All right. Built-in Open API support. So ASP.NET Core in .NET 9 now has built-in support for generating Open API specs, both for minimal APIs and controller-based APIs. The spec can be generated either at runtime or as part of your build. You can also customize the Open API spec using transformers. And this allows you to test your APIs and use them with a rich ecosystem of testing libraries and tools that leverage the Open API standard. The new Open API support is also native AOT compatible. So if you're using native AOT compilation with your APIs, you can continue to use Open API support with this new feature. So let's go take a look at that. I think we can close this app down and this. And let's go to Visual Studio and to our API project. So in Program CS for the API project, you should be able to see, yeah, right here, that we're using the new OpenAPI support. We're setting up the OpenAPI services and then also mapping the OpenAPI endpoint so that the OpenAPI spec is actually addressable. Now there is a package that you also need to add to get this support, and that's this new Microsoft ASP.NET Core OpenAPI package, which has been updated to support OpenAPI generation. All right, now to see this in action, let's just, I'm just going to select just the Web API project and let's get it running. Let's see if we can take a look at the OpenAPI spec. Let's browse to the root of the app, and I think it's OpenAPI/v1.json is where we serve it by default, and there it is. Okay, so there's our OpenAPI spec. It's got all the information about our weather API endpoint, and it's got the full JSON schema definition for our data type. New in .NET 9 also is a JSON schema generation support. Okay, so that's pretty nice. Now we don't include any built-in like UI testing tool for your APIs, but that's okay. There's a whole ecosystem of tools out there that you can use. I'm sure many of you are familiar with like the Swagger UI that comes with like the swashbuckle libraries. You can certainly continue to use that. Or there's other options in the ecosystem, like I think there's one from Scalar. There's a really nice API testing tool. So we can add that to this app to make it easier to see and test our API endpoints. Let's go to our API project and say let's manage NuGet packages. And I'll use the Swagger UI one since I know a bunch of people are probably familiar with that and want to know how can they enable that experience. So if I search for Swagger UI, and I'm going to use the swashbuckle Swagger UI package. Oh, and it looks like my network connection is having some issues. See if I can get that up. Nope. Well, that's my. There we go. Okay, let's try it again. I don't know what's going on with my network. Can we try one more time? Swagger UI. Oh, there we go. Okay, now we're cooking. Yeah, okay, so I'm going to use this swashbuckle Swagger UI package. Let's go ahead and install that into the application. Great, and then once that's installed, we should be able to go into Program CS, and right here, let's do app.use Swagger UI. And we need to pass in some options just to let it know where our OpenAPI spec is. So Swagger endpoint. And we use that same address as we had before, OpenAPI v1.json. And I think this also wants me to give it a name. I'll just call it the weather API. All right. And now if we restart this, once that's up and going, okay, we should be able to go to the browser, and we can now browse to /Swagger. And there's the good old Swagger UI. We can then browse to our endpoint, try it out, issue a request, and see, yep, it's returning all of our weather forecast data. Okay, so that's the new built-in OpenAPI support. Right out of the box, supports native AOT compilation, and you can then integrate with a rich ecosystem of OpenAPI tooling. Now for SignalR developers, there's a bunch of SignalR improvements in .NET 9. SignalR now also supports native AOT compilation, so you can use native AOT with your SignalR hubs. We also enabled polymorphic type support. So if you want your hub method to like take a base type and then you want to send it a derived type from that base type, that now works. And we've also made a bunch of improvements to the SignalR tracing so that instead of getting like one big long activity, you now see individual activities for each of the hub method invocations, which is much easier to read and reason about. For distributed caching, we've got some nice improvements for doing distributed caching in .NET 9. We have the existing iDistributed cache abstraction that's been around for a good long while, but it's a fairly low-level API. It doesn't provide any serialization support. It's just you get a method and you ask for the cache key and you get a byte array back. So that's not particularly convenient, and it tends to allocate a lot of byte arrays as a result, so not super efficient. And it doesn't protect against cache stampedes. Like if you have a bunch of requests that all come in for the same cache key and they miss, then they'll all result in hits to the database. There's nothing that coordinates them to make sure that only one hits the database and the rest get the cache. And it's just a single caching tier, right? Like it's not doing in-memory caching and also distributed caching. It just does the distributed caching part. So in .NET 9, we've introduced a new API, a hybrid cache API that makes things much, much simpler. It just works for most cases. It includes built-in serialization support. It has built-in stampede protection. It's a hybrid, multi-layer cache. So it will do both in-memory caching and then fall back to distributed caching, like to Redis, and then fall back to your actual data source. It's an efficient, low allocation API, so much more performant, and it supports a whole bunch of other advanced options and features like tagging and invalidation and so forth. It works with existing cache backends, so you can use it with Redis and so on. And what's really cool also is that it also supports older versions of .NET. So if you want to use it with, like, say, .NET 8, you can do that. It's not strictly speaking required to be used with .NET 9. So this is what the new code looks like. Much, much simpler. It's just a single API call. You pass in your cache key, you pass in the data, the method for getting the data, and then the cancellation token, and it just takes care of the rest. Much, much simpler. Now, technically, Hybrid Cache actually right now is still in preview. It didn't quite ship a stable release today, but it will ship a stable release shortly. It's expected to ship a release with the next .NET Extensions update. So look forward to that. Lastly, we have a bunch of developer experience improvements in .NET 9 for ASP.NET Core. You can now trust the ASP.NET Core developer certificate on Linux. So for all you Linux fans out there that prefer to dev on a Linux box, you can now set up HTTPS using the ASP.NET Core developer certificate. We added endpoint metadata to the developer exception page, so it's easier to debug endpoint-aware features or endpoint routing-related features. And then we also improved the debugging experience when doing Blazor WebAssembly, and also when just dealing with dictionaries. And this is actually a generic feature. It's not specific to ASP.NET Core, but ASP.NET Core uses a lot of dictionaries, so it's certainly very convenient when doing web development. I'll show you a couple of these developer experience improvements just really quick. Let's close this and get back to Visual Studio. All right, so let me shut down the previous app. And what I'm going to do is I'm going to run this app now with debugging. I'm going to select the app host project and say, let's run the app, but I want to debug. And this should actually pop up two browsers. It will pop up the dashboard, the .NET Aspire dashboard, which shows me the whole application. But because my app is also using WebAssembly, it will pop up another browser that's set up to enable me to debug .NET code running on WebAssembly in that browser instance. Okay, so there's the developer dashboard coming up. And then we should also get a second browser instance that should let me debug my WebAssembly code. Just give that a second to fire up. There it comes. OK, so there's the second browser. And so this is all set up so that Visual Studio can attach to it and debug .NET code running on WebAssembly. So let's make sure we're actually running on WebAssembly first. So there's that auto runner mode. Let's give it a second and let the WebAssembly code download. And there it goes. OK, so now we're running on WebAssembly. And I'm going to set up a breakpoint in my counter component right here, like so. Great. And then let's click the button so we hit our breakpoint. And a couple of things I want you to notice. First of all, notice that the current count is an actual .NET int instead of a JavaScript number. It's super nice. Previously, because of the way this debugging experience works, some of the JavaScript isms of running in a browser would bleed through into the .NET debugging experience for Blazor WebAssembly. But now we're getting a much higher fidelity .NET debugging experience. If we look at the call stack, it's much cleaner now. We don't see any JavaScript gobbledygook. We're just seeing a clean .NET call stack. A lot of the Visual Studio debugging features now work properly, like just my code, or if I load up the modules window, everything loads properly in the modules window. And the expression parsing is also much more robust. Like if I, in the immediate window check, like what's the current render mode name right here, yeah, there, it works just fine. We got WebAssembly. I'm not sure what happened up there above. Cool. So this is actually in preview with Visual Studio 17.13 Preview 1, which is also shipping today, and it's specific to .NET 9. I'll let that go ahead and continue through. Now on the server, one other thing I'll show is that if we go to our Web API project and go to Program CS, and let's set a breakpoint in our API endpoint, if we then browse to the weather page and hit that, there we go. Now if we go into the HTTP context, we should be able to dig in here. Let's go into the context and look at request. And let's look at the headers, which is a dictionary, right? Yeah, there we go. And we can see we get a much nicer dictionary view in the debugger. We can see all of our keys and the values in a nice flat list. Super convenient when you're debugging your ASP.NET Core application. So those are some of the new debugging improvements for Blazor WebAssembly and just general purpose ASP.NET Core debugging. All right, so there's obviously lots of new stuff in .NET 9 for web developers. We have wonderful sessions coming up later in the conference that dive into these features more deeply. Safia and Mike are going to be talking about the new Open API support later today. Beth and Elon are going to talk about the improvements to Blazor hybrid development later today as well. And then I think it's tomorrow, Mark has a talk really going deep into the new hybrid cache API. So I hope you enjoyed learning about these new features. And if you haven't already gone and installed .NET 9, make sure you do so as soon as all the bits have gone live and been fully published, and give the features a shot. Thank you for listening.